When we have neurological disease, or simply as we age, we lose muscle. While you might assume this is due to problems with the muscle itself, this is false. Muscles are both very resilient and very good at repairing themselves. Strength and coordination are controlled mainly by motor neurons in the brain itself. In fact, every movement we learn is like a little computer program which can be replayed on demand to trigger the right muscle fibers to perform any action we desire. As these motor neurons die off, these muscle fibers become inert and they're unusable, and this causes the muscle itself to atrophy over time. Eventually, this becomes such a problem we can no longer engage in our favorite day-to-day activities.
It's as easy as crushing an ant. You know, the... Hey, take my wallet and leave me alone!
I'll crush you like a paper cup.
While many people obsess about possible muscle loss while fasting, it can help a lot with keeping your muscles and brain healthy. In fact, long-term studies have shown that fasts from 36 to 96 hours tend to increase muscle mass over time while you also lose fat. This is partly due to growth hormone released during fasting, but fasting also releases BDNF, or brain-derived neurotrophin factor, which leads to the creation of new neurons. While it was once believed this was impossible, we now know stem cells can create new neurons, which can then migrate to the place in the brain or other organs where they're needed. This includes the nose, and fasting can quickly resolve issues like lost or malfunctioning sense of smell, which can otherwise be permanent and very annoying. Fasting is also highly beneficial for your mitochondria, and most neurological disease is really mitochondrial in nature. Neurons have much more mitochondria than any other cell in the body, but this means your brain cells also produce more reactive oxygen species and other toxic byproducts. This problem is worsened by the existence of the blood-brain barrier, which makes it impossible for the brain to burn free fatty acids. In spite of what the average fitness influencer believes, free fatty acids are the main fuel source for the human body. The only time this changes is during prolonged, intense exercise, when there's not enough oxygen to meet the body's energy needs without using glucose as fuel, which does not require oxygen. Glucose is much more messy as a fuel than fat, and produces at least 66% more reactive oxygen species and acidity than fat burning. This is one of the reasons that, in spite of what vegans claim, meat is not acidic as compared to burning carbs. Fat burning actually skips the first step in the mitochondrial transport chain completely, and this is where most of the damaging and acidic byproducts are created. Instead, it enters in the second step of the cycle, and thereby completely circumnavigating most of the damage that cellular metabolism causes in the body. The second step of the process also creates ATP for use in the third and fourth step in the process, and the fourth step is the cleanup process. So while the first step, glycolysis with carbs, doesn't really clean up after itself, the second step actually generates the cleanup that you need in order to go through the process without causing lots of byproducts. And that's why we have such a big difference in how much negative byproducts are generated between burning fat and burning carbs. This constant carb burning in the brain leads to a great deal of toxins to form in your neurons, such as malondialdehyde, which forms when unstable fats like linoleic acid from veg oil combine with reactive oxygen species. This is a genotoxin that damages mitochondrial DNA over time, and these DNA are much more delicate than those found in the nucleus. Neurons have lots of mitochondria, but when the mitochondria in a cell run out, the cell dies or becomes senescent, which can eventually lead to cancer. Having your brain burn carbohydrate your whole life would seem to be a major design flaw, but your body has an answer: ketones. Your body is not really designed so that your brain will run on carbs, but so it will run on ketones. The whole purpose of ketones is for use as a fuel in the brain where free fatty acids can't venture, and everywhere else they really don't have any point because there's plenty of free fatty acids available. You're born in ketosis, and if you eat a low-carb diet like our ancestors did before the advent of farming, you're going to stay in a state of low-level ketosis for your entire life. Your body will still make some glucose, but this is also made out of fat, and it comes from the glycerol backbone found in triglycerides, which is the way that the body stores fat. It is only the red blood cells that require glucose to operate, as they simply don't have a nucleus and therefore can't burn fat, which requires oxygen. So you can see this is the intended fuel of the brain, and what shows this even further is the fact that the brain prefers ketones over glucose by a factor of at least 2 to 1 when they're available in similar amounts.
If the brain prefers any fuel, it is ketone. Very often, informed people will say the brain prefers glucose, and I don't know of any evidence to suggest that's true. The most damning evidence against that view, against the view that glucose is the primary fuel, is in fact available in humans, not to mention my own data that we've published before and will continue to publish on. But we know that when humans have equal levels of ketones or glucose in their blood, let's just say they were both at 5 millimolar, which would be very normal for glucose, but would be considered quite high for ketones because the average person has none. But when glucose and ketones are at the same level, the brain has shifted so dramatically to using ketones that as far as the brain's concerned, it's now using about 2 to 1 ketone to glucose, if not 3 to 1. So there's a clear preference that when given equal chance from both fuels, the brain has shifted to rely dramatically more, 2 or 3 times more on ketones than glucose.
Another benefit of ketones is that the liver removes any deuterized hydrogen from the fat molecules it packs into ketones. That means your brain will not be damaged by deuterium, which is a ubiquitous problem of metabolism that leads to mitochondrial damage over time. A tiny bottle of zero deuterium water costs well over $100, but the water produced from ketones is 100% deuterium free and also costs you no money. This is not only safe for the brain, but will help the brain a great deal when you're suffering from cancer or from neurological issues. This is an overlooked but very important benefit of ketones, and one of the things that makes it obvious that ketones are one of the most important things for your health. A ketogenic diet will increase ketones, but an extended fast will increase them much more and has many, many benefits besides ketones, especially for those who have neurological issues including MS, Parkinson's, Alzheimer's, and other dementia, ALS or Lou Gehrig's, and even Huntington's chorea. Phototherapy also helps a lot with mitochondrial health. While it is promoted by some, we should look at red light around dawn and avoid blue light like it's poison. You can use red light at any time, and if you do, it will more than make up for the so-called damage of the blue light. When red light hits mitochondria, it affects mitochondrial complex 4 in a way that increases the cleanup of energy metabolism, and this has remarkable benefits. This also undoes any of the so-called damage from blue light, which increases cellular respiration and therefore toxic byproducts. But I would say that this is simply activating the cell, it's not damaging it. It also releases nitric oxide, so it's going to help a lot with blood flow. Obviously, this will also be good for your neurons. Ultimately, your brain needs as much oxygen as possible to be healthy, and this and other benefits of phototherapy help a great deal in neurodegenerative diseases.
I'll talk about behavior, and I'll talk about the neuroprotection of photobiomodulation in this model, because really neuroprotection is the holy grail. It's the at present no current treatment for the disease stops the progression of the disease. All the treatments are largely symptomatic. So really it's the holy grail for neuroscience. So looking at behavior, firstly I'll show you an open field test, and this is like these images here are like you're looking at the cage front on. So this is the top of the cage and this is the bottom of the cage. And the camera was in front of the cage, and that was linked to a computer, and it monitored the movement of the animal over a 20-minute period. And you could see here for the control, over that 20-minute period, the animal was very, very active. It was going up and down the cage, up, down the cage. The Parkinsonian animal, which was treated with the toxin MPTP, which is a well-known toxin for the disease, didn't move at all. It was very akinetic and very Parkinsonian. But look at the light-treated animal. This one was moving around the cage, not quite as much as the control, but certainly much more than the one that wasn't treated with light. Now, this model is not called the gold standard of animal models for nothing. These animals do develop quite Parkinsonian signs, so they become akinetic. They're rigid. Some of them develop tremor. So we were able to score them clinically in the same way we'd score human patients. And the higher the score, then the greater the impairment, motor impairment. And you could see here that the controls had a clinical score of 0. That makes sense. They weren't Parkinsonian at all. You see the Parkinsonian animals had quite a high clinical score. But all the light-treated animals had a much, much lower mean clinical scores. Some of them hardly had clinical scores of 1 or 2, and we did 11 of these light-treated animals. So we have an improvement in behavior and a big reduction in clinical scoring. And now for the Holy Grail. Is it neuroprotective? We counted the number of cells in the substantia nigra pars compacta. We also looked at the termination patterns in the striatum. And as most of you may know, the striatum is where the main dopaminergic synapse is in the brain. It's where the bulk of the communication happens and the dopaminergic neurotransmission happens. And it's where most of the drugs work. So the striatum is really the central hub of dopaminergic transmission. And you can see here that there were less cells and terminals in the Parkinsonian animals. That's good. That indicates that our model was effective. But you see in both terms of cell number and terminal density, there were always more cells and terminations in the light-treated animals compared to the Parkinsonian animals. Not quite as much as the controls, but certainly much more than the Parkinsonian animals.
Phototherapy has also been shown to have a direct effect on muscle growth and is incredibly useful for injuries and tendon health. I spent 2 years in agony when I hurt my shoulder, totally unable to work out. It literally hurt all the time, and anytime I moved my arm, it was agonizing. Once I started red light on my shoulder before trying to work out, I was able to start working out again, and I would still get some pain afterwards, but anytime I did, I just used the phototherapy and it cleared right up. Phototherapy is also shown to release neuronal stem cells, which is very important for neuronal growth. And unlike fasting, there's no effort involved. You just have to sit back and let the technology do its work. It does cost some money, but it is a one-time investment, not very expensive. At least not if you get the same device that I did, which is a red light near-infrared combo bulb. I would start with just one. If you want more, you can always get more. A Juve device with the same power sells for about $800, so it really is a good deal. I don't think you're going to find anything much better at this time. Methylene blue also has a profound effect on your mitochondria and neurons. It increases ATP production in cells while simultaneously increasing the cleanup of reactive oxygen species, which leads to a much healthier environment for neurons. I take 20 milligrams a day, and a good dose for most people is 5 to 20 milligrams a day. Methylene blue also increases the effect of red light and near-infrared therapy because it will absorb these energy spectrums. That means combining methylene blue with phototherapy will have an even stronger effect. Just be sure to understand that you can have too much of a good thing, and while it's difficult to have too much with just the red light alone, If you add them together and then you do it for a long period, then you could really be doing too much. Taurine and glycine also help a great deal with your mitochondrial health. I take 6 grams a day of each, and there's a list of supplements in the description along with my current fasting routine. And most of these supplements are going to either directly or indirectly help your mitochondria and your neurons. Inamin and niacin can also help with neuronal health. And inamin is basically an expensive flush-free version of niacin. Both are proven to be effective in increasing NAD+ within your cells. For that matter, so is fasting and taurine. And there's other things that can do it as well. But these are the main things. And while inamin was very expensive not that long ago, it's actually gotten a lot cheaper. So if you get it in bulk powder form, it's probably not that expensive. Just make sure to take at least an equal amount of TMG with your niacin or your inamin. I take 250 milligrams of niacin a day and 1 gram of TMG per day. I also have videos on each of these supplements, and it is advisable for most people to take all of them every day, which is easy because they're relatively inexpensive. The methylene blue can be expensive, but if you buy it as a bulk powder, then it's much more reasonable. Now, I got my last batch at the CZTL, and that looks like a good company, but it was a little pricey, so there might be other options out there that are a little cheaper. Exercise can also increase BDNF, and this will slow down muscle loss by creating new motor neurons. But don't put your jogging shoes on just yet. Daily exercise, especially cardio, doesn't seem to do much for this purpose. And that's because you're not doing something new and intensely enough in order to stimulate your motor neurons properly. Resistance training, on the other hand, does, i.e. weightlifting. This makes perfect sense if you know how exercise calls upon motor neurons to activate muscle fibers. If you do a light movement, only a few of your fibers are activated, and hardly any of your motor neurons are activated. This isn't random either, it happens in a set order each time. So don't think you can do an exercise 50 times and eventually fire all of these neurons and fibers. You'll just fire the same small percentage every time, and you're just wasting your time. To stimulate your neurons, you need to put forth real effort. This may sound scary if you were older, but it's actually volume that leads to injury. That is the total amount of weight that you lift. So does variation in form, because your tendons are like little ropes, and it's safe to pull them in one direction straight on once your body is accustomed to it. But when you flail them around, it unravels the cross links and frays them, and this leads to injury. So while you want to put in a solid effort, you also don't want to ego lift or keep pushing once it becomes difficult to control the weight. So if you're an older person, you don't want to make it too hard to recover from. So I'd suggest just a single set of 5 for each lift, and to very slowly increase the weight over time, and to not do too much to start with, and only continue to do what you're comfortable with. That's enough to fully stimulate your motor neurons, but not going to cause enough wear and tear to lead to injury. Just make sure that you do slowly work up the weight over time. Just don't do it too fast. Remember, we're not trying to become super strong or big when we have disease or aging related issues. We want to stimulate those neurons without getting injured. This will ensure we don't lose them, because once we do, the muscle fibers they control are useless. This is also the way to increase tendon strength over time, though anything that stimulates blood flow will also help, especially phototherapy. Progression over time is the key to success with weightlifting, but the fad today is excessive volume and very rapid progression. Both of these trends will lead to injury and quick plateau in progress. If you progress slowly and keep volume low, you'll seldom stall in your progress, if ever, and you'll have very little chance for injury. After a few workouts where you can easily do all 5 repetitions while maintaining full control, go up in weight, but never do this more than once a week, and once a month or less is probably a better idea once you're used to it and progression is slower. And if you get to the point where you're as strong as the average guy and you don't get worse, then you're doing well if you're trying to avoid losing muscle, and that's all you really need to do. But if you ever have trouble recovering or pain during the lift itself, reduce your weight to half the current value on that lift and start over again. That should resolve any minor issues before they become big issues. and you will get back to your original strength much sooner than you think. If you're younger and you do want to have bigger muscles, it's simple. Do the same thing, just add in some more volume, and make sure to push yourself harder.
Jump, 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 and rest. What are you doing, man? I'm resting, it's going all grey. That's the pain barrier, beat it. You're right, you're absolutely right. Keep it going, and rest. Brilliant, that extra little bit, that's what it's all about.
However, you really don't need more sets of 5. One set is enough to increase your strength as far as it will go, because all you have to do is hit all of those motor neurons in order to increase strength over time. You don't need to wear them out. This is proven by 19th and early 20th century strongmen who did very few reps and increased their strength very slowly. One set of 5 and 2 to 3 sets of 10 to 15 on top of that to add in some extra volume will be more than enough to get you to your maximum size over time. You can add in other techniques like drop sets or supersets or whatever on top of this, but it's the progression in strength over time that will drive all your progress, and if you don't progress there, then you're not progressing anywhere. I've done very complicated schemes over the years, pretty much everything imaginable, but over time I saw this is all you really need. A little bit of work in the lower rep range, and then whatever volume you can recover from on top of that. As for what exercises to do, that's a topic that many books have been written about, but any group of exercises that balance pushing and pulling and do at least some work for your legs should suffice. I would just avoid doing barbell squats if you have bad knees or if you're older. If your balance is not perfect, this can become a very dangerous exercise. So if you're over 50, you may want to consider something else. Goblet squats where you hold a dumbbell in front of you are more than enough for those over 50, and special techniques can also make this exercise useful for younger people, such as standing on a plate while you do it, which will hit the quads much more. This will make things harder without having to use more weight and without the added danger. Fasting, phototherapy, and strength training, methylene blue, taurine, and glycine, all of these can help stave off the degeneration of neurons in the brain, and this is the root cause of muscle loss and aging, movement disorders, and weakness, which is associated with neurodegenerative diseases. Muscle loss is somewhat inevitable as we age, and for neurodegenerative disease, but with the right changes, we can push it off to a much later date.
We will travel to the rift sticks, where you will place a coin.
Not today, matey.
In the mold.
Remember, only the good die young.